All right, so we touched on this a little bit already. This will look familiar. We did this before. That jacuzzi holds 60 gallons and it's draining water. So it's going down every minute and then finally it gets to here and it stops. Well, today we're really going to go revisit this, but really focus on what do these mean? How would you interpret it in a real life way so it makes sense? Instead of just saying it stops at 6 times 0, what does that mean realistically? Okay. So in other words, can you look at this and say that, well, we know the x is the minutes and the y is the gallons, so this 6 stands for 6 minutes and this 0 stands for 0 gallons, and then come up with some sort of statement that summarizes what this point actually means. It's significant because it's at the end, where we're going to be looking at the end points. These are also called intercept points. X-intercept is, of course, where it crosses the x-axis. The y-intercept is, you guys already know, where it crosses the y-axis. But once you see these endpoints and you have the information of the units, can you interpret it so it actually means something, like how we really talk? So this is kind of correct, I'd say, but there's something kind of off about it. And it means, since 6 stands for minutes, after 6 minutes, there are 0 gallons left. Now, would you ever say, after 6 minutes there were 0 gallons? Or if you look into a bucket and they said how much water in there, would you say, oh, there's 0 gallons? Probably not. So I would take out this phrase, and instead of just doing the literal translation, like, okay, 6 minutes, after 6 minutes, 0 gallons, 0 gallons. Make it more realistic. Instead of saying 0 gallons, what word would you use? Empty. Empty. After 6 minutes, it was empty. Make it more real. I mean, yes, that's the same thing as 0 gallons, but we don't talk like that. So that's what the assignment really is today, is interpreting the math in a realistic way. So if you had to explain this to somebody else or each other, it'd be in a language they would understand. Like you would not say, you two people looking at a bucket, you'd both say it's empty, not 0 gallons. Okay, so focus on that. This means there's going to be a lot of different ways of saying the same thing. This is okay. Okay, so here's a good example. Mine's exploring 90 feet underground. After 1 minute, elevator is taking them up to 60 feet below. Assume they go at this constant rate until they reach the surface. So where would this start graphically? And the graph we give you kind of gives it away. You notice how this does not go to 90, right? How come it's down here? Yeah. So once again, this is about interpreting. If I didn't give you this graph at all, that went down negative but not positive, would you put together that underground would be a negative? Even though it says 90 feet, and okay, that's positive 90 in the sentence, you interpret this as 90 feet underground means negative 90 feet. Okay? That kind of thing. No math step, there's no do this to both sides. It's just understanding the question in the right way. Okay, so, yeah, this would be 0, negative 90. By the way, what are the units for x? Time, what are the units? Minutes, yeah. So this always helps. And what are the units for the y-axis? Feet, yeah. This is what we're going to use in our explanation at the end. Okay, so we go, let's see here. After 1 minute, we're at 60 feet below. Again, 60 feet below, you have to interpret that as that negative 60. So after 1 minute, right, minutes, 1 minute, negative 60. Oh, we can see kind of like a slope going on. We're going up 30 feet in 1 minute. Up 30 feet in 1 minute. Up 30 feet in 1 minute. Should I keep going? Why not? What's that? We're at the surface. So again, when we were graphing, we just drew a line through everything, put an arrow on both sides. But we have to know that, well, we're assuming that this elevator starts down here and it stops up here. It doesn't go up in the sky. Right? And when you think about it, it's kind of ridiculous. Oh yeah, that's right. It has to start at the surface going in on the line has to go and stop right here. And then if you graphed it, of course, you guys would use the straight edge, but it would stop. It's important that you know that it does not keep on going. We don't do this thing where we put an arrow through it and keep doing it, have to keep going. It stops. Again, it's not a math thing. Well, it is a math thing, but it's more of a logic, like, oh yeah, the elevator stops at the surface. Okay, this coordinate is 3, 0. What would this mean? What would 3, 0 mean in regular language? Again, use the, it took 3 minutes, because X are minutes, and we wouldn't say, oh, after 3 minutes we were at 0 feet. We'd say it took 3 minutes to get to the surface, and that's it. Okay. So this is what you'll be doing in your homework. You'll have the intercept. You'll say the intercept means it took 3 minutes, write it all out, to get to the surface. You can just write the whole thing out. And you might do for the y-intercept as well. We started at 90 feet below the ground. The y-intercept is a little bit easier. It kind of gives it to us in the question. It tells you where you're starting. But the x-intercept is kind of where you're finishing. So that's the gist of what you're doing. Interpreting a problem, making a realistic explanation on what's going on. By the way, you should be able to do this for any point. So if I gave you, like, what does this point mean? You should be able to say, oh, after 2 minutes, we were only 30 feet below ground. After 1 minute, we were 60 feet. Any of these points, we can do that. This one just happens to be more significant since it's the end. And this one, since it's the beginning. So y-intercept beginning, x-intercept is the end. Let's do a few more. Oh, by the way, I keep on using that word intercept. That's just where we're 2 points, where 2 lines cross. So where really our line crosses where the x-axis and the y-axis. Or intersection, 2 roads crossing, intersection, same root word, intercept. All right, so read this, go ahead and read this. Again, the good place to start is, what are the units? What are the units for x here? Feet? Or hours? Yeah, which is which? Yeah, usually the x-axis is time. Anytime time is involved, we put it here. That way when we read the graph, we can see what's happening from left to right over time. And then up here would be our feet, our distance, or our dollars is usually on the y-axis. Okay, so this helps. So what you can do is say, okay, these coordinates are going to be hours first, comma, feet. If we don't do this correctly and we switch it, of course, our explanations are going to be all backwards. This is actually very important. So this means after 0 hours, we're 1,000 feet. What does this mean in layman's terms? Basically this right here. We started at 1,000 feet. After 0 hours at the beginning, we're at 1,000 feet. Basically, you're just reiterating what they already said. We started at 1,000 feet. It seems redundant, but that's okay. Now, what does 10, 0 mean? 10 hours, we were 0 feet. But how would you say that in more realistic terms? Yeah. After 10 hours, he is at the base of the mountain. Something like that. We are making one assumption with a pronoun here. 10 hours he or she made it to the bottom of the mountain. Something like that. Hiked to the bottom, I'll say that. Hiked. Oh, does it? It doesn't climb. Oh, over here. Okay. Can't see. After 10 hours, he hiked to the bottom of the mountain. Something like that. You could say base of the mountain, but you wouldn't say after 10 hours he was at 0 feet. It doesn't. You wouldn't say that in real life, so we're not going to do that here. Make it realistic. Again, a lot of it has to do with that first step. What are gains? Okay. So you guys figure out this one. This one we intentionally wanted them both to be the same numbers. What does 0, 16 mean, and what does 16, 0 mean? So far, what's been the first step I've always done? What is that? Labels, yeah. What does X mean? What does Y mean in this problem? So what does X stand for? What's the units? What is it? Minutes. And Y is, must be the pages. So now we can actually interpret these correctly. I know first number is minutes, these are pages. Okay, so after 0 minutes, 16 pages. What does that mean? Yeah, before we started, we had 16 pages to read. Okay, no problem. What about 16, 0? After 16 minutes, we want to say after 16 minutes we had 0 pages. Really? How much do you have to read? How much left do you have to read? 0 pages? No, we don't say that, right? After 16 minutes we finished reading, or we read it all, or something like that. But be realistic in how you would actually talk. Sometimes the easiest way to know if your answer is good is you just say it out loud. Whatever you write down, say it out loud. Does it make sense? Is this how you'd normally talk? And if so, it's probably correct. If it sounds like weird, like you're trying to sound like somebody else or sound too technical, then you probably need to simplify it a little bit. So yeah, after 16 minutes, we finish reading because there's no more pages left. Something to that effect. Okay? And again, last time I'll say it, the key lies with knowing what the units are. Okay, lastly, does a particular equation have to have both intercepts? Not necessarily. So if it's starting here and going up, it could not have an x-intercept. And if you try to think about, well, what would an x-intercept mean here? And it doesn't make sense. So depending on the problem, it may or may not have both of them. They'll definitely have a y-intercept because these are all going to be functions. But it may not have an x-intercept. Okay? So we might only have to interpret the y-intercept, which would mean, of course, here, the base fee before anything was $50. After 0 passengers, right? Passengers will be the unit here. This would be dollars. Again, money is usually the y-axis, almost always. Now, does this graph keep on going up and up and up forever? Or does it stop somewhere? And why would it stop? What's that? Yeah, good. Because it can seem like, well, we always just put arrows on it, but we're talking about a raft here. Can we just keep this graph going and have like 100 people? No. So at some point, this raft is full. Okay? So yeah, this will actually stop. Let's say this raft only held 6 passengers. That means the graph would actually stop right here, which means the max that they could get would be $140. So again, reading the problem, you notice how that had really nothing to do with, okay, step 1 is this, step 2 is this, then you divide by both sides. It's, you have to understand that, well, graphs can only hold a certain amount of people, and that's it. You can't keep this going and have 1,000 people on this graph. Okay. More interpretation. And how many people fit on it doesn't tell you, but at least we know it has some limit. So even though it's not an intercept, it's still a stopping point, which is kind of like an intercept. It still serves the same thing. So you'll be reading these and be thinking about this, like, well, does it stop or does it keep going? Yeah. Okay, so that's one type of problem. Here's a real-life problem. Interpret what the graph means in real life. The other is, what if you already have an equation, and I want you to find this without graphing? Find a y-intercept without graphing. And find an x-intercept without graphing. These are the same equations. How can we do that without graphing? X-intercepts and y-intercepts. Okay. There's no units or anything, it's just an equation. So if we revisit here, what do you notice about the coordinates? What do they have in common? Well, these have 16 in common and 0 in common. Okay. And if you go back again, what do these have in common? 0. Right? So that's our way in that intercepts are when one of the coordinates is 0. So if I want to find an y-intercept, that's where x equals 0. If I want to find an x-intercept, that's where y equals 0. So if I just have an equation, you can just plug in x equals 0 or y equals 0, depending on the intercept you're trying to find. So if I go here, find the y-intercept, this is code, you need to understand what the directions mean. That means plug in x equals 0. So they want to know, where is it crossing the y-axis? Right? That means the left and right distance is 0. I'm not going left or not going right. So x is 0. So for all of these, the answer will be 0 comma something. Right? And just plug in 0 for x. All right. 100 plus 5 times 0, and you'll get your answer, 100. We can do the same thing for x-intercepts. Okay, that just means plug in y equals 0. There's a little more solving. We'd have to do, remember this is the same as y, this symbol here. So we have 0 equals 100 plus 5x. Subtract 100 on both sides, and divide by 5 on both sides, and we get x equals negative 20. So x-intercepts usually have a little more solving. So then, of course, x was negative 20, y was 0. So we have the coordinates we know is the negative 20 comma 0. And from the first one, we know it's 0 comma 100. These are the same equations. So we could, with those 2 points, we could go ahead and just graph the line if we were asked to. All right, we can pass out the homework. We can do a few on there together. So let's look at our the first question on the homework is number 2, right? So a dolphin is 42 feet underwater, ascends at a constant rate of for 14 seconds until it reaches the surface. Okay, so we got to interpret this. What does 42 feet mean? Well, that would be 42 feet up here, but it does say underwater, right? So once again, we have to interpret it, not just say this is positive 42, so that's it. We have negative 42 is right here. And what does this mean? After 14 seconds, it reaches the surface. surface means what? How many feet is that? 0 feet. So again, we have to interpret this information and know, oh, that's 14, 0. Okay, that's right here. So any given situation, this, there might be a word that stands for, a value. In this case, surface means 0 feet. And again, you can use a straight edge just to connect those. No rise, no run, and it stops. It doesn't keep on going. It doesn't go down more, it doesn't go up more. Once you're at the surface, the elevator or the dolphin is not going to start flying in the air, right? So if you think about, well, what would it mean if this graph kept on going? That means you have a flying dolphin. So use common sense, real life reasoning, and it'll make this seem a lot easier. If you try to memorize and do steps, it doesn't really work so well. All right, lastly, I'm going to show you what we did just a second ago. Number 3, no graph, no word problem, just find the intercepts. And remember, for the x-intercept, this is the important part. For the x-intercept, it's where y equals 0. For the y-intercept, it's where x equals 0. So y-intercept is always something, 0, and an x-intercept is always 0, something. So we're plugging in 0 for each one. And we're going to do both for each equation, because we want both. So a good way of organizing your work is this. And let's do x, abbreviate x dash int. We know it's okay for the x-intercept. X-intercept, y is 0, so I'm going to plug in 0 for y. 2x minus 3 times 0 equals -6. Simplify that, get your answer. The zeros are just going to really go away because 0 times anything is 0, and then 2x minus 0 is just 2x. So it simplifies rather quickly. And then divide both sides. X equals -3. Now the very last thing is write it as a coordinate. Remember, this is like a graph. Where would it cross? So what's the coordinate where this actually happens? Yeah, so the x is -3, so x coordinate's -3. Remember, we plugged in y equals 0 right here, so the y is 0. That crosses that -3, 0. Draw a little squiggly line, and do the same process, but for the y-intercept, which means x equals 0. X equals 0. We have 2 times 0 minus 3y equals -6. 0 minus 3y is just going to be the -3y equals -6. Y equals, what is it, -2? Is that right? Positive. Negative over negative? Positive. And the coordinate? Yeah. We plugged in 0 for x. Our y equals 2. So if you're asked to, furthermore, if you're asked to graph this, -3, 0, be like right here. 0, 2, be like right here. And there's your graph. You don't have to do that part, but just know that that would let you graph it as well. Okay, good luck.